the second session of the strings and arrays class. Okay. All right, so just as an overview for what we'll be doing today, it's a lot similar to the previous lab sessions we've done before. So we're going to cover a little more content. I know this week we're covering a lot of different techniques. So last session we talked about the two-pointer approach, and then this session we'll talk about sorting and binary search. So both these are really common approaches and really helpful tools to utilize when you're doing interview problems. So it's good to know how to use these, and it's good to always keep these in mind. So if you need to review these concepts, I'd highly recommend you review them. For the session today, I'm just going to talk about them very briefly. We'll jump into mock interview sessions. We'll review those questions really quickly, and then we'll kind of just do a quick wrap up. But before that, I just wanted to congratulate everyone for making it to week 6. I know there's been a lot of material, but thank you guys for sticking through with the class and getting through all of the kind of warm-up problems, the hacker ranks. I know there's a lot of content, so congrats. Okay, cool. So let me jump right into sorting. I'm not going to be discussing how each of these sorting algorithms work, but just in general, it's always a great tool to consider if it'll help make a problem easier. So sorting is not specific to simply arrays of numbers, so it's also a good tool to consider when you're working with strings as well. So just in general, I think when you're given a string or array problem and you're really stumped, always think about, will sorting make this problem a bit easier? It's also like a good question to ask when you're given an array of numbers or you're given a string, like, can you assume it's sorted? Normally for strings, at least, you can't make that assumption that's sorted, but also with arrays, you can just ask that to your interviewer as well. And just in general, you won't need to implement sorting. I haven't had to do that in my personal experience. I don't really ask people to do that. It's more just that you need to know that sorting exists and that for whatever language you're comfortable in, you should know how to do a sort. And I think even though you won't be asked to implement sorting, you should actually just understand the mechanics of popular sorting algorithms. So I've outlined the ones that I think you should be aware of. You should know merge sort, you should know quick sort, radix sort, insertion sort, and selection sort. And you should kind of know the runtimes associated with each one. So hopefully they're not too complicated, at least with like insertion sort and selection sort, those are pretty straightforward. In general, you can make the assumption that whatever sorting algorithm you'll be choosing will, in worst case, be n log n if you're just utilizing like a sort function that's built in. And for those of you who aren't super comfortable with these sorting algorithms, everything is covered in one of the guides I wrote up for this. It's like the sorting guide, so definitely go through and review that if you aren't super comfortable with these. Cool. So the last kind of thing we're covering this week is binary search. So binary search is a really common technique that's utilized. So it's good to know kind of how it works. So, and actually not just how it works, but you should be super comfortable implementing it. So it's really useful tool when you're kind of working with the sorted array, and it's log n runtime. So the basic gist of it is, let's say we're looking for the number 23 in this 10 element sorted array. What you basically do is you'll pick the middle element and you will sort, or you will basically pick the middle element and see, is it bigger or less than the element we're looking at? And if it is bigger than the element we're looking at, in this case, we're trying to find the 23, it's bigger than the 16, we'll move and half the problem space, which is the size of the array, and we'll look at the half of the array starting from 16 to the end of the array. We'll kind of repeat the same process. We look at the middle between 23 and 91. We look at 56, and because 56 is bigger than the element we're looking at, we go through and look at the range between 23 and 38, and that eventually lands you to 23. the reason it's a really helpful tool is because instead of looking up an element utilizing by like going through every single thing in the array, that'll be O of n time, you're having the problem space each time. Oh, someone says, if we're generally not asked sorting questions, in what situations are sorting algorithms useful? I think the merge algorithm is helpful in some linked list questions. So I'm kind of reading through some of the comments there. So I think in general, if you kind of looked at the solution for the group anagram problems, they kind of utilize elements of these different sorting. I'm going to go back. So I think the concept of radix sort is good to know just because you might be asked to implement radix sort. So radix sort is possibly like an algorithm you have to implement, but that's a pretty straightforward problem. So I think it's sometimes like if you need to utilize sort, and sort is a big like a core part of the problem, sometimes you might be expected to implement the sorting if, for example, you know the number is constrained to be maybe only in the hundreds, then radix sort yields like a super optimal runtime. It's O of n instead of n log n. In that case, you might have to implement radix sort. So in general, a lot of times I just tell the interviewer that I'm going to sort the method and it's n log n, but there might be cases in which, for example, because the input is constrained, you can utilize radix sort and it's more optimal than a merge sort. Yeah, I think the concept of merge sort is helpful in that it's like a divide and conquer technique for sorting an array, and the kind of like divide and conquer technique is utilized in a lot of different problems, so it's kind of good to understand how that works. Yeah, in general, I think if like the conversation with your interviewer kind of gets into the mechanics of sorting, they kind of at least expect you to know what the runtime is associated with each one in like the worst case or like the best case. Okay, cool. All right. Diving back into binary search. Yeah, so someone mentioned like insertion sort is faster if the array is almost sorted, radix sort is better if you have lots of repeated elements. So yeah, I think it's just good to know the trade-off in general. Okay, cool. So with that being said, I kind of just wanted to walk through a problem with binary search. So it's not just useful for like looking up elements in arrays, it can also be actually useful for problems that in which you kind of need to speed up calculations. So for example, let's go through this problem really quickly. You're asked to implement the square root of number. You can compute and return the square root of x, where x is guaranteed to be a non-negative integer. And the return type is an integer, so the decimal digits are truncated and only the integer part of the result is returned. So if you look at the examples here, when you're given a 4, it's really easy to do 4 because it's a 2, but in the example where the square root is a decimal number, then we just simply truncate and return that 2. So with the 8, it's a 2. Cool. All right, so the first approach in which you can solve this problem is simply to brute force it. And you basically try to square every number from 0 to the target number until we reach that target number, right? So this is kind of the bad square root. So we take everything from the range basically 0 to x, and if it returns, basically if the square of it is the number we're looking for, we return I, and if the number is greater than what we're looking for, it means we need to take the previous numbers because the square root falls in the range of like a decimal. So Then we simply return I minus 1, and the runtime of this is simply just grows with the size of x, right? Or, sorry, the square root of n, but it's effectively not that great because it kind of grows with that size of x. And then how can this be improved? So in optimized square root of x, what you can basically do is you can basically apply binary search to find the square root of x, right? So find the middle number between 0 and x. If the square of the middle number is x, then that means we're done. Pretty simple. Else the square root of the middle number is greater than x, then we'll repeat this process from the range 0 to the middle number. And then in the case where basically the square of the middle number is less than x, then we'll repeat this process with the range from the middle number to x. So what's the runtime of this approach? Does anyone have an idea? Cool, yeah, 7 instead log x. Awesome, yeah, it's way better than what we were doing before. We are now cutting the basic problem space in half by each time. All right, so here's the code I wrote up optimized with binary search. So basically I have the square root function that we'll be calling to get the answer, but I think when you're implementing binary search, it's actually helpful to utilize a helper to track kind of like the low and the high point of the range you're looking at and whatever target you're looking for. So in this case, the square root simply just calls square root helper, and square root helper does more of the work. The square root helper, you feed it basically a low point of the range, the high point of the range, and the target you're looking for. And basically, I've taken the pseudocode I wrote out in the previous slide and just implemented it. So the code for binary search is honestly pretty simple, but I think what kind of happens with binary search is it's easy to have like off by 1 errors. So if you haven't done it before, definitely implement it, go through a few problems, try implementing it a few times. It's just a very common type of solution that could come up, honestly, with high probability in like one of the interviews you're doing. Okay, so before we kind of wrap up the content for this week, there's actually an advanced topic that we don't really cover, but I'd highly recommend you learn about if you aren't really familiar with this data structure. So we don't really talk about it. Yeah, we don't talk about it actually, but I just wanted to ensure that everyone is aware of what this is, and if you have time, maybe in one of the review weeks, kind of try and go through doing one of the problems with tries. So you could go to LeetCode and they have problems tagged with try, and I'd highly recommend at least going through 1 or 2 problems with tries because it could come up. So a trie is also sometimes known as a prefix tree, and it's basically a type of tree that stores strings. And the basic concept of a trie is that you start off with a node, and each node basically stores a character, and the children of that node is just simply the letters from A to Z. And it's like a recursive definition where for each of the children, that child has children that are A to Z. So in that case, the common usage of tries a lot of times is when you are doing like a type ahead. That's a really common try solution where, let's say you wanted to autocomplete. Basically, the idea is you can utilize a try to store all the common autocomplete words, or like the words people utilize, and when someone types in a part or like a prefix of a word, you can basically utilize the try to figure out what the different recommendations you can give for that prefix is. So basically the idea is that each path down a tree represents either a prefix or the whole word. And it's really great for string lookup. So a lot of times if you need to store a lot of different strings, tries are a really common data structure to utilize. So if we look at the try on the right, we can actually walk through a quick example. So you'll start off with the root of the tree. that doesn't really store a character, but the root of the tree has children, and each of the children are basically representing one character there. In this example, I think I pulled it off of the internet, and for example, for some reason they capitalized the A, but in the most cases you use just case insensitive, you're just simply storing that string. So in this example here, let's say we're trying to store the word 10. You'll start off with the root, you'll go to the node that contains the T, and basically you repeat this process with the rest of the string, the E, the N. So if you look at this tree to the right, it'll go down to the node with the T, and then you'll go down to the node with the E, and then you'll end up with a terminal node, which is the N right there. And that's kind of how you go through and store the different words. So in a different example, in the bin example, INN, you kind of repeat the same process. You go to the node that stores the I, and then you go to the next node that stores the N, and then you go to the next node that stores the N, and you end up with in. So notice that for the case of T, TED, and 10, actually all three of them start off with the path from T to E. So they start at T, and then they go to E, and then they end up in different nodes there. Cool, so I just wanted to briefly touch on this data structure, make sure you guys are aware that it exists, but to actually, I think, fully understand how to utilize it, you should definitely go through a few problems. The problems themselves, I think, tend to be pretty straightforward once you're comfortable with the idea of a try and you know how to implement a try. And there's a great HackerRank video that covers the implementation. I linked it here. So after class or when you have some time, I'd highly recommend you go through the implementation. The implementation I don't think is too bad. It's kind of this recursive data structure. Yeah, awesome. Cool. With that being said, we'll kind of jump into mock interviews for the rest of class. So the mock interview session this time, only 15 minutes to kind of read through the doc for each problem. For 45 minutes, we'll do the first mock interview, and then for 45 minutes, we'll do the second mock interview. And we'll send out announcements between each segment. The problems this week are a little bit more challenging, which is why there's a little bit more time for you guys to cover the different problems. And for the mock interview prep, just wanted to reiterate that you should read the problem, come up with some other test cases, spend time trying to think of a solution, read through the solution, and go through a few examples with the solution. I know 15 minutes isn't a lot, but try to do as much of this as you can. So when you're kind of going through the solution, just grab a pen and paper. And I think sometimes it's helpful when you're looking at a solution to manually kind of walk through what that solution is doing and come up with some hints if you have some time. And for the mock interview expectations, we expect that you have an ongoing conversation. You should have some pseudocode and example input and output before you jump into implementation. The other thing I noticed was that some people only did the pseudocode and didn't go into actually implementing the code itself, even though there was leftover time. So you guys should do what I did in the last session, where I actually went through, converted the pseudocode into actual code. I ran through a lot of different examples to validate that my code was actually working. So before we kind of call time on that second question, make sure you've done this very extensively before moving on. I don't want to jump into rooms where I've only seen the pseudocode and I didn't see any implementation. I didn't see any actual running of the code. And yeah, I really want to ensure that people are doing that before they jump into the next problem. Because at the end of the day, it's a really useful skill to have, to know how to debug. And I don't think it's something we practice enough of if we just do pseudocode. And aside from that, I'll kind of jump into rooms, and if I don't see a clear kind of like time slice complexity on the doc, I'll kind of jump into rooms and ask if you guys have done this. I just want to ensure that you guys are doing this with each question that you're doing, because it's once again something your interviewers will expect you to do. And just as a don't look at the solution together during the interview. There's time left over at the end of class. The docs are all there, so don't do that before you actually try to tackle the problem. And don't use LeetCode to test your code. You should kind of be doing what I was doing in the last session, where I generated a ton of different test cases to see if I could break my code. That's also a skill you need to practice for real life interviews. And the last thing that I think people are getting a lot better at doing is just ensuring that at least one screen is shared when you're doing these mock interviews. So the person who is doing the interview should be sharing their screen. And that makes it a lot easier for us TAs and me to jump in and just see what's happening and try to help if we see an issue, and try to chime in and ensure that everything is going correctly. And if you ever have any questions, some people have been utilizing this, but definitely use Zoom raise your hand feature. It lets us know that you're struggling or you have some problem, and then we'll just jump in and try to help. And the reminders are all the instructions will be out here. So if you go to the week 2 tab, once again, just a reminder, you guys should be familiar with this by now. And yeah, just one person each will go through each one of these problems. There will be 45 minutes for each round. And with that being said, Elena, can you break out the rooms into groups of 2?
Yep.
Thanks. To jump into quite a few rooms. So what I really enjoyed seeing was people actually trying to implement the code and trying to debug the code. So that was really great to see. So just as a recap for the 2 different questions we did, I think the 2 different questions are pretty different. The max chunks to make sorted, I think it's trickier to understand what the problem is asking and kind of to gain that intuition of how to solve the problem itself. So I jumped into one of the rooms and someone had a good question. Someone felt like they were spending a lot of time trying to come up with the examples and trying to understand the problem. In general, I think a good rule of thumb is to try to generate an example that is slightly more complex than maybe some of the examples they've given. And I think it's worthwhile to do so to ensure that you fully understand the problem, so that once you actually try and tackle the problem, you're not trying to solve the wrong problem. And the other nice purpose of coming up with a slightly more complex test case is that you can then utilize that at the end to test your own code. So with that being said, I think the right balance is to try to come up with a test case that's slightly more complex than maybe some of the test cases they give you, but not so complex that it's really challenging for you to solve that test case. So you want to sit somewhere in the middle when you're trying to come up with your own test cases. So it's a pretty tricky problem to understand for this one. I think when you're walking through your own examples to try and understand the question, try to potentially notice patterns. So with max chunks to make sorted, try to notice, hey, like when I'm given a list, at what point do I know that I can cut off this chunk and split these up? Like, how do I determine these points in which I can split them into chunks? And what is the intuition behind that? I think in general, I think you're going to see more of this pop up, is that in general, like pre-processing inputs can be helpful and worthwhile. So I think a common pre-processing technique is maybe you'll keep a running minimum where you store a separate array that keeps track of the minimum at each point, at each index in that array, or vice versa, where you keep track of the running maximum and you utilize that. And with those operations, it's only simply constant time in terms of just going through, not constant, just linear. So it's just linear time going through that array and strings. So that's generally a worthwhile approach. It might take up, well, it does take up more space complexity to do so, but it just in general, it's a really common technique that I've seen pop up in a lot of array questions. So I think pre-processing, super effective technique, definitely something to keep in mind when you're working with array problems. And the second problem, basic calculator, I think is more challenging in a different sense. So I think basic calculator is more challenging to implement. So if you look at kind of like the optimal code for make chunks sorted, it's a lot smaller than all the code you kind of have to write out for basic calculator to work. So I think basic calculator, the reason I chose this as a problem is I think there are a lot of these like different calculator-esque problems, and I think it's important to kind of have a high-level understanding of how to approach these problems and all the different kind of like cases you have to consider when you're given a parsing sort of problem. So we did something kind of similar but slightly less complex with the reverse Polish notation in the past. I just wanted to expose you guys to a slightly more challenging problem that's kind of similar. So for this problem, there are like many different ways you can structure a solution to this question. So I provided one valid approach, but there are different ways in which someone could come up with a legitimate solution for this problem as well. So I think more or less it is just a good practice problem with parsing and getting really comfortable trying to debug parsing problems and trying to understand parsing problems. I think if you're able to do basic calculator and you can get a working solution for that, you can probably be pretty confident with parsing problems in general. So just as a wrap up, the last thing I wanted to say with the two different guides is the solution I put up there is in general like a somewhat optimal solution. So I think if someone is able to come up with a solution that utilizes the same time and space complexity, that's fine. The solution is just kind of one approach in doing it. Cool. So with that being said, I just wanted to wrap up all the content from this week. I think we covered a lot. I think so far this week might have the most techniques and different approaches we're covering. So just as a wrap up, what I think is important from this week is that you learn your array and string libraries for the languages you're comfortable in coding. Be super comfortable with 2D matrices. 2D matrices are really common and you should be able to do it. Like you should be able to write that double for loop to traverse through a matrix really well. You should be comfortable debugging it, just be very comfortable working with them. And the other thing is two-pointer approach. Definitely understand how that works and be comfortable with implementing that. And the last thing would be binary search. So review that, understand how to implement it, and you should just be able to utilize that as a tool. And then sorting as well, just understand how the different sorting algorithms work and what scenarios is one sorting algorithm better than the other. So understand kind of the mechanics behind the different sorting algorithms. Cool. With that being said, there's a lot of content here. Try and spend the time to go through all these different things we talked about. There's a lot of different guides this week to cover. And if you're not super comfortable with them, try going through the different problems. There are a lot of different problems for each of these different techniques we're teaching. There are always, as always, there are video walkthroughs. Generally on the weeks in which we're introducing new content, there should be a corresponding video walkthrough. And the video walkthrough actually, the ones I created go through the process of everything. So starting from reading the problem, doing the pseudocode, coding up the problem, and then testing the problem, everything is there in that video walkthrough. And as always, you always have a ton of practice. Go through the in-class exercises. I know a lot of people weren't able to finish both mock interview questions. So if you weren't able to go through those, try to understand how those work, especially for the one in which you didn't code up, ensure that you are able to code up in the solution on your own. So always post assessment questions that you can go through, and that's just to provide you guys with more practice. And as always, there's a HackerRank due, so be sure to get that done. And with that being said, I'm actually not teaching for a while, so I'm not teaching until the last week of class. If you ever have any feedback, if you ever have any questions, feel free to Slack me. So if there's something, yeah, I forgot to mention this, but if there's anything from the previous weeks you wish could be improved, let me know. This is kind of like a work in progress, and we're trying to make sure that the class is constantly being improved. Oh, okay. So what's happening next week is that we kind of wanted you guys to have a catch-up week. So there's a project. I am not super familiar with the logistics of the project, but what I can do is ask the TA who organized the project to discuss that more. I'll note that down. Okay. Cool. Sorry, today's class went slightly over time, but I'm still going to stick around. If you guys have any questions, you can ask me now, or you can also message me on Slack. I'll also respond.
Thank you.
Did anyone have any questions? I'm just going to monitor the Zoom group chat until we run out of questions. And they can be about anything. Oh, okay, cool. Someone mentioned if you go to week 7, there's a link to the project write-up. It's pretty detailed on what you're supposed to do. Yeah, if anyone has any questions in general for all the content we've covered so far, feel free to ask me now. Any questions in general about internships, jobs, interviewing, I'll stick around to answer. Someone asked, do you have experience interviewing at Nordstrom? Unfortunately, I have not done that. But if there are any other companies that you want, did they give you, okay, so they gave you an online assessment. Was it like a hacker rank type of thing? Okay. I've done a few like coding challenges before, so I'm not really sure how Nordstrom structures it. In general, the coding challenges I guess I've done tend to be like 1 to 2 hour long, and I think the most important thing is that with the coding challenges, sometimes, okay, so it's 1 hour 45 minutes for 2 questions. Okay. Yeah, I think in general, just make sure that once you come up with a solution for the 2 problems, you actually spend the time to try to clean up your code after. So there's a high possibility that the interviewers will actually go through and look at the quality of your code. Yeah. Oh, okay, cool. Someone said, I've heard the Amazon interviews are strange. Do you have any experience with that? I think with big companies, the interview experience can be highly variable. So I think what's unique about Amazon, I personally haven't done Amazon, but I know Amazon will ask like behavioral questions, at least for industry hires. So I think if you look up like on the internet, some of the questions they could potentially ask, there's a lot of content there. But no, I have not had Amazon interviews before. But from what I know, talking to different friends, a lot of it is whiteboarding, and depending on the person, they have very different experiences. I think that's just the case with like Microsoft, Google. The only thing that I know is different about Amazon is just these behavioral type questions they'll ask. Oh, interesting. Someone says for the internship, Amazon makes you do a logical assessment. I was not aware of that, but that's good to know. I think in general, also, if anyone has any questions, I think you should ask the general class chat, because there are a ton of people in that class chat. And as you can see from this conversation, some people might have gone through the process before and can shed some insight on their experiences there. So I'd highly recommend you utilize like the class group chat to ask people about their experiences at these different companies and their experiences with interviewing at these different companies. I'm pretty limited in terms of like the number of companies I'd interviewed at, and yeah, the coverage is as great with just me. So if you reach out to the whole class, it's likely that someone has done it before and might answer. Oh, someone says, can we have a question and answer place like Piazza? Oh, that's interesting. I'll ask about it. That's a good suggestion. I'm not sure if they've tried that before. Okay, is it better to code the solution that works for the given input and optimize it later for the given input and optimize it later to be correct for all inputs, or find the correct solution and then code it? Oh, I see. Yeah, so generally the way I like to approach questions is I like to code up a solution that works for, that's a good question. Okay, so ideally you're coding up a solution that will work for all inputs, if that makes sense, right? So I think you can let the interviewer know, hey, like there are certain edge cases in terms of like maybe the input could be really strange, and I think it's okay not to handle all of that initially, but in general, your solution should tackle most inputs that are, in terms of like complex inputs, those should all be handled. I'm not sure if my answer makes sense, but the basic idea is I think with all weird, strange input cases, it's okay that your code might not handle that, as long as your code is handling like more complex cases where like, so a good example would be for the calculator case, right? With the input, you can have a lot of really weird, like, what if I'm given input that where the expression is not valid? So in that case, I think it's okay where you tell the interviewer, hey, I'm going to code up maybe a solution that works for all cases in which the input is valid, and then I'll go back and handle cases in which it is invalid. But your code should be working for all the valid cases that are starting from like the very simple list valid cases 1 + 2 all the way to the super complex like nested parentheses case. Those should be handled. Yeah, I think what I've heard is a good approach is sometimes as you're building up to a good solution, sometimes what people will do is if your interviewer tells you the objective of this interview is that we want working code by the end of it, sometimes it's helpful to run your code through the simplest cases and kind of like build up to the most complex one. We try to answer as many questions as we can, but sometimes we kind of we'll miss some of the conversations that's happening there. Did anyone else have any other questions? If it's unclear what I said too, I'll try to expand on that as well. I guess for those of you who are still here, what has been your favorite part of the class? I'd love to get a pulse of like what I think has been really helpful so far, what maybe could be better, getting some feedback, and I'll try to pass that on to the TAs for the future weeks as well, if anyone has any feedback they want to give. Who was on the project in Teams? I think we outlined everything in the doc there. Let's see. I believe they're solo projects. Yeah, the point of the project is we wanted for you guys to had like a less stressful week and practice just coding up, doing some more coding. Okay.
Okay, let's see. Please come to the rooms and practice. Awesome, as it helps us practicing really fun.
Awesome. That's good to hear.
Okay, so I guess, is there anything? I see. So there's a preference to work on the questions together. I didn't like that the mock interviews as much since the interviewer and interviewee are both new to the problem. Okay,
That's
good feedback. Instructions are confusing. Okay, that's good to know.
Yeah, so it's a little tricky because with mock interview questions, what we want to do is we want to simulate the environment of a real type of interview, but it's hard to scale that up with a class with 100 people. I'm not sure that we have the best approach right now. The idea is that we want you guys, so realistically in an interview, you're not working with someone else to try to tackle a problem. And honestly, from personal experience, when you simulate a real life interview setting, I think that's just the best form of practice. So for example, the max chunks to make sorted problem, I think sometimes you just have to go through and just be uncomfortable. Like a lot of times when I'm working on more challenging problems, I am in a similar boat where I can just be stuck. So I think understanding how to make incremental progress, even though you're stuck in a mock interview setting, is just a good skill to have, and not letting like your nerves get to you. So I think when you work on problems in pairs, it doesn't expose you to the setting in which you're kind of uncomfortable and you're kind of trying to make progress on your own. Cool. I'll give feedback to the TAs that they're really helpful. Okay. And with the hackering feedback, if there are any problems that were especially confusing, feel free to reach out to the TA and let them know. We're trying to make those better as well. Oh, someone said for this problem, we noticed that we're able to separate the chunks. Oh yeah, sorry, there might be a typo in that one. I'll go through and fix that up. Thank you guys for giving all the positive and negative feedback. It helps because honestly, when I'm talking to you guys, it's all silence and I don't really get feedback on what's going well and what's not going well. So it's really helpful to get feedback so that in the future weeks, we can try to incorporate more of that feedback into the class. Yeah, I guess since I'm not here for the next 6 weeks, and I feel like I maybe should have done this earlier, but I'm curious like what aspect of the lecture you guys have enjoyed the most. So do you prefer like walkthroughs? What do you want to see more of, and what have you enjoyed seeing? Walkthroughs? Okay, cool. Good to know. So having the walkthroughs are good. Of leak code hards. Okay. I'm just writing these things down. Cool, that's good to know. So it seems like Have interviews with instructors, TAs would be awesome. Okay. Interviews, instructors, TAs. Oh, is that like you want to see a walkthrough of an example interview, or would you want to do sessions with instructors, TAs? Oh, I see. Got it, got it. Yeah, okay. So looking at all the questions we have right here. Mentorship program, honestly, I don't know how the mechanics of that work. I've been reading the chats and trying to understand what's happening there, but I don't really understand. It's, I think, a relatively new thing. So if there's any feedback you want to give, I think everyone is pretty responsive on that general group Slack messaging. So ask questions there. I think it's the first time they're trying to do it. Yeah, I think it's honestly, that's interesting. It is really challenging to scale up to 100 people and try to do mock interviews with all 100 people, unfortunately. Okay, that being said, any last remaining questions? I'm gonna hop off soon if there are no more questions. I haven't received a mentor assignment yet, but I think I filled out the form. Should I wait for some time to receive an assignment? I think, okay, let me take a look at what's happening in the Slack group right there. I think you can reach out to Morgan Richardson. It seems like Morgan is the one organizing everything. So if there are any questions in which you feel like you're not sure if you filled out the form, feel free to ping her. Oh, it's first come, first serve. Okay. All right, guys. I'll see you around for the last week of class. Good job on all the hard work. I know this class is a lot, especially for those of you guys who are in classes right now or interning right now. So good work. I know it's quite challenging, but I think if you're able to get through all 12 weeks of the course, you'll probably kill it and do a lot better in interviews. Bye, guys.